Hello everyone, welcome to Design and Analysis of Algorithms. Today we will be discussing about brute force algorithms. So what is the technique that this brute force algorithm employs? We will be discussing about that. How do these brute force algorithms work? These algorithms, they use a straightforward method of solving a given problem. The algorithm will go through all the possibilities of solutions extensively. So which means that it has to go through several try and error procedures, and these algorithms which employ brute force technique, they utilize the computing power rather than efficient techniques of solving a problem. Now what is meant by a straightforward approach and what is meant by going through all the different possibilities of solutions? An example can be finding out all the divisors of a given number n. So suppose there is a given number, say 56, and we need to find out all the divisors or all the numbers that completely divide this number 56. So what do? We scan through all the numbers from 0 to n or from 1 to n. We scan all the numbers from 1 to n and then list out all the numbers that completely divide this value or this number 56. So this is what is called as a brute force algorithm or a brute force technique. So we'll be discussing two algorithms which employ this brute force techniques: selection sort and bubble sort. So these two techniques we'll be discussing now. Okay, so the first brute force algorithm that we'll be studying is selection sort. So selection sort is an algorithm which is used to sort an array of elements or a list of elements in either ascending or descending order. Okay. So how does this selection sort algorithm work? So this selection sort algorithm is based on the idea of finding the minimum or maximum element in an unsorted array and then putting that element in its correct position in that sorted array. Now assume that we have this array of these 5 elements, so which needs to be sorted in ascending order. We will consider that we need to sort this array in ascending order. So what do? We scan for the entire list and we find out the minimum element in that array. So the minimum element in that array is 11. So this 11 is searched and then swapped with the element that is located in the first position. So after we find out the minimum element, it will be swapped with the position in the first element. So 64 and 11 will be swapped. Now next, the second minimum element will be searched for, and the second minimum element here is 12 and it will be put in the second position, and this will go on till we reach the end of the list. So this is how selection sort works. So we'll trace out how this thing works. We'll try to trace the logic of this. We have an unsorted array of 5 elements. Now I have a variable here called as min. I have assigned the first value in this array. I have considered that this is the minimum element present in that array. So what I'm going to do is this algorithm is going to compare each and every element with this min, and swapping will take place. So first thing, compare 64 and 25. Since 25 is less than 64, assign min is equal to 25. First what we did was we assigned a variable min and we assigned 64 to that min variable. Then we compared 64 and 25. 25 is less than 64, therefore assign min is equal to 25. Now min is equal to 25. Now next is compare 25 and 12. Now 25 is greater than 12, so assign min is equal to 12. Now the value of min is 12. Next compare 12 and 22. 12 is less than 22, hence min value will remain 12. Next thing, after comparing 22, it is going to compare with 11. So compare 12 and 11. 12 is greater than 11, assign min is equal to 11. Now we have reached the end of the array. After 11 there are no more arrays present. So this value is the minimum value of the array. We have searched for the minimum value of this array. So what do? We swap this minimum array or this minimum element present in the array with the first element. Which is the first element? 64. So swap 64 and 11. So when we do that, 11 will become in the first position and 64 will be placed at the last position. We have to continue this till we sort the entire array. Now on the left hand side we have the sorted array, and on the right hand side we have the unsorted array. Okay, a division is made just to differentiate between sorted and unsorted array. Now the next, we have to start with the second position or the second element now. Assign min is equal to 25. Again go on comparing with each and every element. Compare 25 and 12. 12 is less than 25. Assign min is equal to 12. Now compare 12 and 22. 12 is less than 22. Move to the next element. Compare 12 and 64. 64 is greater than 12. So we have reached the end of the list. So the minimum element now in this remaining unsorted array is 12. So swap it with the second position. So we have to swap 25 and 12. So when we do that, we have 11, 12, 25, 22 and 64. So left hand side we have sorted, right hand side is unsorted. Next, in the third pass, assign value 25 to minimum. Compare 25 and 22. 22 is less than 25, so assign the value 22 to min. Next, compare this min value 22 with 64. 64 is greater than 22 and we have reached the end of the list. So 22 is the most minimum value or the least value here present. So swap it with 25, 22 and 25. So when we do that, we have an entire sorted array: 11, 12, 22, 25 and 64. So this is how the entire selection sort algorithm works. Next, I have written the function or an algorithm, a C function, or you can call it as an algorithm for selection sort. I have two loops over here. Minimum is equal to I. The first element is assigned as minimum. Then comparison takes place. If A of j is less than A of min, then assign the value of minimum to j, and then swapping takes place. When we reach the minimum element in the array, then swapping takes place. So this is the function which performs selection sort. Let's talk about its complexity. Let's calculate its time complexity. So I have two loops, I loop and j loop. I goes from 0 to n minus 2 and j goes from I plus 1 to n minus 1. Next, summation of I equals to 0 to n minus 1. We have seen how to calculate or how to mathematically analyze a non-recursive algorithm. This is a non-recursive algorithm, so I'll be following all the steps which we have seen in the previous video lecture. So this is upper bound minus lower bound plus 1. This 1 is for the one basic operation. So upper bound n minus 1 minus I plus 1 plus 1. So this will evaluate to n minus 1 minus I, minus 1 and plus 1 will cancel. So we'll get this n minus 1 minus I. So substitute the value of I, which goes from 0 to n minus 2 in this equation. So when we substitute values of I, we get n minus 1 plus n minus 2 plus n minus 3. So as we have already seen this will evaluate to n into n minus 1 by 2. So this is n square minus n by 2. So the highest degree of this particular equation is n square. So this is the time complexity of selection sort algorithm. Thank you. The next sorting algorithm under brute force technique we'll see is bubble sort. So this algorithm is also used to sort elements either in ascending or descending order. We'll see how to sort elements in ascending order. So how does bubble sort work? So in this sorting technique, adjacent elements are compared and swapped. Adjacent elements are compared and they are swapped. Let's find out in the first pass what will happen. So this is the list of unsorted elements. So comparison of adjacent elements will be done. So 5 and 1 are adjacent elements. 5 and 1 are adjacent elements. Since 5 is greater than 1, swap the value of 1 and 5. So we'll get 1, 5, 4, 2, 8. Next compare 5 and 4. Since 5 is greater than 4, swap. So we'll get 1, 4, 5, 2, 8. Next compare the elements 5 and 2. Since 5 is greater than 2, swap their positions. So we'll get 1, 4, 2, 5, 8. Next compare 5 and 8. Now no swapping will happen here because 5 is less than 8. So this is the first pass. After the first pass, this is what we will get. So similarly, comparison of adjacent elements and swapping of elements will happen for all the remaining passes. So after all the passes are done, we get a sorted array. So this is the algorithm where adjacent elements are compared. I have two loops over here, I and j. So in this I have this particular statement which compares adjacent elements. If it is greater, then swapping of this of these elements take place. Okay, let's talk about its complexity, time complexity. So we have seen a similar example previously, how to mathematically analyze non-recursive algorithms. So two loops over here, this represents the I loop, this represents j loop, this is lower bound, this is upper bound. So it is upper bound minus lower bound plus 1. This 1 is for the one basic operation. So this is n minus I minus 1 minus 0 plus 1. So this will evaluate to n minus I. So substitute the values of I goes from 0 to n. So substitute 0, 1, 2 up to n. So what we will get is this equation, n minus 1 plus n minus 2. So this will evaluate to n into n minus 1 by 2, which is nothing but n square. So the time complexity of bubble sort algorithm is also n square. So this was about brute force algorithms and the two sorting algorithms which employ brute force technique, that is selection sort and bubble sort. Thank you very much.